everyone, it's Alyssa and welcome to You Can Learn Math.
Today we're talking about the Pythagorean Theorem. The Pythagorean Theorem was named after a mathematician and odd human being named Pythagoras, not because he discovered it, it was actually in use long before he was born. But, as many times things in history happen, even if you're not the one who discovers something, they slap your name on it. So that's what happened here. And the Pythagorean Theorem, which that name is you're going to hear it so many times, I guarantee you, even though it's long, you are going to remember it, has to do with right triangles. A right triangle is a triangle with an angle of 90 degrees in it. So 90 degrees, one angle of 90 degrees. And this little square in the corner tells us that that is a 90-degree angle, even if it doesn't have that little 90-degree number. That square is enough to tell us. And this theorem applies to any triangle with a right angle in it. It can be one with sides that are exactly the same. It can be one that is way, way longer on one side. It doesn't matter. This proportion always works. And here it is. It is a squared plus b squared equals c squared. Well, of course, the first question we want to ask ourselves is, what is represented by a, b, and c? What are they on these triangles? Now, A and B can actually switch places. More on that in a moment. But the one that is always going to be the same and is arguably the most important is C. C is always going to be the hypotenuse of the triangle. Now, the hypotenuse of a right triangle is the longest side. Now, you do not have to have a ruler to find the longest side in a right triangle because, conveniently for us, it is always the one that the right angle is looking at, that this little corner is pointing towards, that little square is pointing towards that opposite side. So that right angle is always opposite the longest side. That is our C. So in each of these, that's the side that is C in this equation. Now, A and B are the other two sides. And again, it doesn't matter which one I assign. I could call this A and this B, or I could call this B and this A. It doesn't matter because they're being added. So if I reorder them, it's the same. The fancy name for this is the commutative property of addition, the commutative property of addition. So it's saying if I had two numbers, 5 plus 3, it's the same as 3 plus 5. That's why it doesn't matter. We can reorder them. So I'm going to call this A, this B. I can call this A and that B, that A and that B. And when we're saying A squared, B squared, and C squared, we're talking about the lengths of these three sides. That if I measure this side, and then I square that number, and then I measure this side and square that number, and add them together, it will equal the length of this side squared. Most of your problems that are given to you involving the Pythagorean theorem, they're going to give you two of the sides and ask you to figure out the remaining side. For example, let's say I had this right triangle and I said this side is 3 and this side over here is 7. What is this other side? Again, we always want to make sure if we are filling in a squared plus b squared equals c squared that we're putting the two sides that were given into the proper places in this theorem. So here, I always want to start with identifying my hypotenuse, C, because that's the one that can't change. C is always C. A and B can switch places. I can call one leg A or I can call it B, and that's fine. But C is absolute. So here I have my right angle, and it is looking at or opposite this side, which is our longest side, our hypotenuse. I don't know what it is, so I'm just going to call it C. I could call it X. I'm going to keep it simple and call it C. So my other two legs are 3 and 7. They are the legs of the right triangle. They are my A and my B. So I'm going to plug them in. I'm going to say that A is 3 and that B is 7. 3 squared is 9. 7 squared is 49, and that's going to equal c squared. 9 plus 49 is 58 equals c squared. And here's where our square root comes in. To solve that c squared equals 58, I need to undo c being squared. To do that, I'm going to take the square root of both sides. So the square root of 58 equals c. Be careful with these when you get to this point. When you get to this point where it's like the square root of a number, make sure that the square root is in its simplest form. If they are asking you to put it in a decimal, do that on your calculator and get that decimal. If they're wanting you to leave it as a square root or as a radical, you'll see that term as well. Make sure to simplify that square root if possible. If you need a refresher on simplifying square roots, a video link is in the description below. It'll walk you through all that. The other type of problem you're going to come across is where it's one of the legs, and they don't give you the leg, but they give you the other two sides. That's why I say it's always important to identify your hypotenuse first thing, so you don't make any mistakes when you're plugging into our a squared plus b squared equals c squared. So let's say this one, say one side was 10, and this side is 20, and they want us to solve for that third side. Now, before I put anything on my little drawing here of my right triangle, I want to make sure I've identified C. I always start with that. Okay, so there's my right angle, and it is opposite or looking at this side right there. So that is my hypotenuse. That is the longest side. It is C. That what I just said there, it being the longest side, that's a good way to kind of check your answer on these. If you get an answer and it's the answer for like this leg over here, and you get a number that is bigger than the hypotenuse, something ain't right. You have made a mistake somewhere or typed a wrong thing in your calculator, because this is always going to be the longest side. The other two will be shorter. So, okay, I've identified my hypotenuse, my C. So I'm going to put it here for C. And this 10 can be A or B. It doesn't matter. I'm going to call it A, and I'm going to call this side B. So I'm going to plug 10 in for A. My B stays like that. Okay. So I have 10 squared, which is 100, plus B squared equals 20 squared, which is 400. Now just a couple of quick little algebra steps to help me solve this equation. B squared has 100 added to it. So to undo that, I'm going to subtract 100 from both sides. So that gives me B squared on the left equals 300 on the right. To undo B squared, I'm going to square root both sides. B equals the square root of 300. And this can be simplified to 10 square root of 3. Again, if you need a refresher on simplifying square roots, link is below. So in this case, B is 10 times the square root of 3. And anyone who's done different kinds of fancy right triangles, you may realize, go, hey, does that mean this is a 30, 60, 90 triangle? Why, yes, it does. If that's something you're also working on, link for a video on 30, 60, 90 triangles, and also 45, 45, 90 triangles would be below. So those are the two main types of problems you're going to see with the Pythagorean theorem. Remember this theorem, memorize it, memorize it, memorize it. Put it in your brain for the long term. It is going to keep coming up again and again and again in both algebra, geometry, and later even in trig and such. Just trust me on this. All right, so that's it for Pythagorean theorem.
I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.